introduce Dr. Ravishankar Chattasubramaniam sir, an educator and researcher whose work connects a strong understanding of how physics is learned with innovative teaching practice and educational research. He completed his doctorate in physics education research at Purdue University, USA, where he explored how students learn physics not through memorization but as a process of thinking and reasoning. Through his scholarly work, he has contributed to frameworks such as STEM ways of thinking, which integrate design thinking, scientific concepts, mathematical reasoning, metacognitive reflection, and computational thinking. Beyond research, his teaching philosophy is clearly reflected through his initiative, Physics with Ravishankar. His approach to teaching physics focuses more on curiosity over memorization and understanding over shortcuts. He believes that physics should be experienced as an active process of questioning, reasoning, and exploration rather than the passive absorption of formulas. His teaching encourages the students to engage deeply with concepts, express their thinking, and develop confidence in their own reasoning. He believes that physics is best learned through doing, questioning, and thinking together. We are honored to have such a dedicated educator and researcher with us today, and we look forward to learn from his experience and contributions to physics education. We are proud to say that he is an alumnus of our institution and it is a pleasure for us to welcome him back to our college. With great respect, we extend a warm welcome to Dr. Abhishek. It is my pleasure to introduce Dr. Balakrishnan Viswanathan sir, a theoretical physicist working in the area of quantum science and quantum optics. Dr. Balakrishnan Viswanathan sir completed his undergraduate and master's studies in electrical engineering and later moved into physics for higher studies. He received his PhD in physics from the University of Arkansas, USA in 2020. His PhD research focused on quantum optics, especially how single photons can be used for quantum logical operations, which are important for future quantum technologies. After completing his PhD, he worked as a postdoctoral research fellow at Oklahoma State University, where he studied quantum imaging with undetected photons and explored how quantum principle can improve imaging techniques. Later, he joined the University of Oklahoma as a postdoctoral researcher, where his current research focuses on quantum synchronization, working closely with experimental research groups. Along with his research, Dr. Balakrishnan Viswanathan sir is actively involved in teaching and mentoring students. His interdisciplinary background helps him to explain complex quantum concepts in simple and understandable way and making him especially approachable for students. We are happy to have him with us today for the discussion on teaching quantum science, challenges and the way forward, and we look forward to learn from his experience. Please join me in welcoming Dr. Balakrishnan Viswanathan sir.
It's my great pleasure to introduce Ms. Dipti, an emerging researcher and science communicator who is currently a PhD scholar at VIT Chennai. Specializing in high energy astrophysics, her research focuses on neutrino physics, dark matter candidates, and cosmology, where she leverages advanced tools such as GPU programming, scientific Python, and GNT4 to explore some of the universe's most fundamental mysteries. Ms. Dipti has built a strong academic foundation with master's degree from a physics VIT Vellore, a passion for research and led her to collaborate with leading scientific communities and institutions, including CERN, IIT Madras, ICTS, TIFR, IUCA, and LIGO India, gaining valuable experience in astrophysical relativity, gravitational astronomy, and radio astronomy. Beyond research, she is a dedicated educator and communicator of science. She actively engages students and the public through outreach initiatives, making complex scientific ideas accessible to broader audience. She is managing the social media handle of Anagamina Science Forum to promote scientific curiosity among students. Her dedication to education, leadership in scientific communities, and active engagement in nurturing young minds truly make her remarkable personality. Ms. Dipti represents the next generation of scientists working to deepen our understanding of the universe. Please join me in welcoming Ms. Dipti to share her insights and expertise with us today.
I request our department students to felicitate the panelists. Shankar Narayanan, our classmate, is also the part of panel discussion session. And next, Divya to the visiting instructors. Engage and breathe. Panelists to take over the session.
The topic
Super.
is what can be done to enhance or improve quantum science education. So நாங்கள் டிஸ்கஸ் பண்ணி we came to given the time constraints மூணு டாபிக் bilingual ஆக்கலாம், you can speak in Tamil or Tamil English mixed, doesn't matter. So முதல்ல வந்து we want to talk about why is this topic important, right? அப்புறம் we'll move to the challenges educators face in the classroom and outside when it comes to teaching of quantum science, and of course what could be done next. So in the three parts we plan to discuss, and we also have a way to engage the audience. Deepthi has prepared a menti.com too loud. Okay. Menti.com la ஒரு poll பண்ணிருக்கா. So we encourage the audience to participate. And the QR code will be displayed, and please participate with maximum enthusiasm. So we like to see what you have in mind, and it will be displayed here, of course anonymously. So just to get a feel of the feel of your thoughts, and if there is time, we'll also give a chance for audience to take part in each part. But let's keep it very short. நீங்க பேசுறச்ச few secondsல summarize பண்ணுங்க question or thoughts whatever, so that we can stay within the time, right? When you get a chance to hold the mic, please use, let's say, a few secondsல please communicate your thoughts. Correct? Let's start. Yeah. So முதல்ல the point is why is quantum science important? சொல்லி கொடுக்குறோமா கிளாஸ்ல ஸ்டூடெண்ட்ஸ்க்கு எப்படி என்ன யூஸ், ஸ்டூடெண்ட் அதை வச்சு என்ன பண்ண போறாங்க, வாட் இஸ் இட் தே கோயிங் டு டு, இஸ் இட் இம்பார்ட்டன்ட் அப்படின்னு that's the first question. Any thoughts? Who can start? Deepthi?
Yeah, so in my opinion, it is definitely needed. As much as we need computers or math for every subject, quantum has become one such tool. It has evolved from being a very niche subject to becoming a tool. So I believe it's very, very essential for anybody to learn quantum. In fact, quantum physics, instead of saying quantum physics, adavida quantum science, it's very aptly named, this colloquium, because it has become a very fundamental science to say. With the evolution of science in the past 100 years, initially people who were, say, in the early 1900s, people who were in the commerce side, people who were studying commerce, may not have studied science to that much of an extent. But by the 2000s, even people who have studied commerce have some basic knowledge of science. So now, with the evolution, the difference between that time and this time is the time taken for the evolution to happen. Back then it took 100 years, now it's taken 25 years. ஸோ அப்போ இருந்த அந்த எவல்யூஷன்ல காமர்ஸ் பீப்புள் கூட வந்து ஒரு பேசிக் சயின்ஸ் நாலேஜோட தான் தேர் ஆப்ரேட்டிங். இன்ஃபேக்ட் ஈவன் இன்வெஸ்ட்மெண்ட்ஸ் ஆர் மேட் பேஸ்ட் ஆன் ஹவு மச் ஆஃப் சயின்டிஃபிக் நாலேஜ் தே ஹாவ் டு சூஸ் விச் கம்பெனி தே வாண்ட் டு இன்வெஸ்ட் ஆன். ஸோ ஸ்பீக்கிங் இன் தட் சென்ஸ், ரைட் நவ் குவாண்டம் சயின்ஸ் ஹஸ் becoming essential, and in that way that everybody is going to need it as a tool. So irrespective of what branch you're studying, maybe right now it may not feel so important, I feel. It may not feel so important the same way that artificial intelligence did not feel as important back in 2015. When the first ever neural networks came into existence, people didn't think much of it. They just felt that, okay, humans can teach machine to work by themselves, but right now machines are putting humans out of their jobs. So first time it happened, second time it shouldn't catch us so off guard. So it's better to be prepared. So that, in my opinion, that is the case.
இந்த பேனலில் இட்ஸ் ஒன் இன்ட்ரெஸ்டிங் திங் இஸ் நான் வந்து ஒரு டீச்சர் மோஸ்ட் ப்ரைமர்லி a டீச்சர் அவங்கெல்லாம் கொஞ்சம் ஆக்டிவ் ரீசர்ச்சர்ஸ் அண்ட் ஒன் இஸ் இன்ட்ரெஸ்டிங் இஸ் த ஸ்டூடெண்ட் ஸோ பிளெண்ட் இருக்குது கைண்ட் ஆஃப் ஸ்பெக்ட்ரம் ஸோ என்னோட பாயிண்ட் ஆஃப் வியூ எல்லாமே பி ஃப்ரம் பாயிண்ட் ஆஃப் வியூ இஸ் அ டீச்சர் ஸோ அவங்க ரீசர்ச்சர்ஸ் ஸோ அவங்க பெர்ஸ்பெக்டிவ் ஐ திங்க் வில் ஹேவ் மோர் வெயிட்.
So, the explosion that has taken place over the last 100 years in both fundamental science and the applications certainly put quantum mechanics at the center stage. So today, if anyone wants to have a career in research, certainly a good training in quantum mechanics is essential. But having said that, so many people use quantum mechanics these days, right from those who do fundamental research all the way to people who work on engineering, like nanoelectronics, people who are into quantum technology. So when we say teaching quantum mechanics to people, it also should also keep in mind to what kind of audience are we teaching. So maybe somebody who wants to pursue fundamental research and fundamental theoretical physics like quantum field theory may want to appreciate quantum mechanics in a particular way, but an electrical engineer who would want to work on quantum photonics, so on and so forth, may want to appreciate it slightly differently. So it's important to teach quantum mechanics in a way that would be helpful to people to realize their ultimate goal. So quantum mechanics is essential. There is no in this day and age, so there's no true opinion about it, but one size doesn't fit all. I don't think we can have a single formula to teach quantum mechanics to people across the spectrum.
Thank you, Bala. Shankar, your thoughts on why as a student you think it's a value in learning quantum mechanics?
Firstly, quantum mechanics is kind of hard to follow intuitively. So initially students, especially from senior secondary or high schooling, because students have been working on deriving equations of motion, they have been working on parameters which are deterministic, whereas in quantum mechanics, the issue with quantum mechanics, or more than issue, that's what nature is, that is how nature works. So for a student to learn new set of equations, to look at physics from a different point of view, that's number one, that's what future requires, because most of the modern technologies that we are talking about, be it quantum cryptography, be it quantum communication or quantum computing, I think understanding the basic understanding it right from the fundamental level is something that is very essential. So I always try to have quantum mechanics into school syllabus. One of the reasons why I always support this point is that quantum mechanics is a subject that tells us what nature is. So, and physics being a subject that works on the revealing of truth, quantum mechanics, I think it's a reflection of how nature works, and that tells us what nature is truly, what nature's true potential is.
Very good. Thank you, Shankar. Another point I like to add. Now, I learned physics from my teacher, Professor Anandan, who was a teacher here in Vaishnav College. I became a student the year he retired, 1991-92 at the time. So, another teacher, physics is a way of thinking. So, quantum physics is a way of thinking. You learn how to think, and I think there's a value in learning how to think, and there's a value in learning thinking deeply, right? Another, I never asked this question, why should I read quantum mechanics, why should I read என்னோட டீச்சர் ஒரு எக்ஸாம்பிள் சொல்லுவார், கதை சொல்லுவார். ஒரு கதை, Edmund Hillary. Somebody asked him, why did you go and climb Mount Everest? Right? His answer was, because it is there. Right? அவ்வளோதான் சிம்பிள். ஸோ நான் அப்போ ஃபிசிக்ஸ் எப்படி படிக்கிறேன்னா, இருக்கு, இன்ட்ரெஸ்டிங்காக இருக்குது, என்னோட மைண்டுக்கு ஆக்குபைஸ் மை டைம் அண்ட் மைண்ட், அண்ட் ஐ ஃபைண்ட் இட் எக்ஸைட்டிங், அவ்வளோதான். ஸோ அதை வச்சு யூஸ் பண்ணி அப்ளிகேஷன் தான் இருக்கான்னு எனக்கு தெரியாது, ஐ டோன்ட் நோ, ரைட்? பட் there's a value in engaging deeply with the topic, right? And that's what research is all about. Research but learning learning deeper than it's not like you do physics, BSc, MSc, after you become a researcher. What were you doing all along? Correct. It's not like you finish your schooling, you finish get your MSc degree, then I say tomorrow, from day after, I will want to become a researcher. And what were you doing all along? படிக்கிறச்சே research பண்ணா படிக்கணும். Quantum mechanics படிக்கிறச்சே postulate சொல்றா, அந்த postulate எப்படி வருது? Who gave the postulates? And the postulate எப்படி theory use பண்ணறா? Right? I think there's a logic there. Geometry mari. You have the postulates of geometry, then you derive the theorem. And they say, hey, this is what is given to prove conclusion. There's a logical flow. And that logical flow, the logical thinking is transferable to any field you go to next. So there is a transferability factor when you learn these fundamental sciences, and that includes quantum physics. Anything else you'd like to add? Shall we start the poll or add something?
Yeah, I think we're good to go for the poll.
Poll? I think that'll be good to see what the audience thinks. Right?
Yeah, Menti and the slides the first one.
அங்கே ஒரு menti.com ஒரு வெப்சைட் இருக்கும். நீங்கள் மொபைல் ஃபோன் எடுத்துக்கோங்க. அந்த QR கோட் you can scan. தமிழ் புரியும் இல்லையா எல்லாருக்கும்? Right. Yeah, this is the first question we have.
Once again.
No, yeah. Please be honest. Anyway, it's anonymous, so nobody will know what response you might have given. What has been your response? What has been your experience been in learning quantum science? These are the options. On the mobile, share some thoughts on what you see.
So, I suppose everybody has had some sort of experience, because I made sure the options were in such a way that you can only answer if you have had experience. So, in some way or the other, you have had experience, it shows. So, I guess it shouldn't be very difficult for anybody who has at least known quantum mechanics to fathom that it is of some use to us. So, you would either right now looking at, so we have 17 for where is it applied, and
That's a good question. Yeah, the people are thinking about
Exactly.
That's a good question, right?
so still trying to make sense of it and where is it applied are the most fundamental question anybody who is studying the subject is going to have. Rest of it is your opinion on the subject. That's not about what how much of use a subject is to you. A subject might be very useful to you, but you might be hating it. A subject might be you might love the subject, but you may end up never using it. So from
Can
what
I interrupt?
yeah.
I also noted that confusing that Professor Natarajan சொன்ன மாதிரி it's fine. If you're confused, I think it's good. At least I think you're asking some deep questions. So and I think that's positive, right? To be confused is okay. Of course, we live in a culture where there's a premium on always being correct. But real research, real learning is opposite of that. You don't need to be correct, and you got to be you have got to get confused, right? So of course, the good thing is majority say it's. I mean, good numbers say it's exciting, and also still trying to make sense of it. So it's a very interesting pool. Can we ask audience to share one thought on one person? One from the audience can keep it short. Your response. One from the audience. Anyone from the audience? Come on. Yeah, come on. One of you can take the mic.
Us having the discussion, it's
Just-
all of us having it.
What are your thoughts?
So I'm a third year BSc student. So I've been studying quantum mechanics for about a year and a half now, and I'm still trying to make sense of a lot of different concepts right now.
That's a lot of perseverance to try for 1.5 years. That's good. Fantastic.
I was initially interested in quantum computing, and I was like, okay, so something that combines both computers and physics, which are both of my interest. So I was like reading about it, and I couldn't actually read about it because I was so confused on the first page that I left it. I left the book as it is, and I was still not.
Which book did you take?
Griffiths.
Griffiths.
So I have still not yet touched it. So I feel like this is a really accurate representation of what it is to me. So it was exciting a bit, but it was also very confusing, and I'm still trying to make sense of it.
Me too. I remember when நான் இப்போ தான் PhD போயிருந்தேன். நான் 2021 போனேன். எனக்கு 20ல அட்மிஷன் கிடச்சிது. But I have now 96 masters and I completely out of just quantum, all these things. So when I sat down and prepared before I went to the US, I took Griffith's book and I couldn't make sense of it. You know, Xi over the differential equation, where the something all is coming up. I didn't know what to do. But what I did was, luckily COVID came, I was very happy I had all the time in my life. Every day I would sit and write something. But in 1 year I could make some sense of it. So one thing is, from my experience, get your hands into it. Get your feet dirty. Get hold of things and pick up any one book and start working out. You will find your way slowly. Anybody else would like to add? Bala would like to add?
Yeah, so when one studies quantum mechanics, probably we should give up the notion that it should make sense the way we are used to in our everyday thinking. So, quantum world is very different from what we have learned in classical physics. So that's the way nature is. So, when we read quantum mechanics, I don't think we should always have this feeling at the back of our mind that somehow we will be able to relate it to what we experience in our everyday life, or what we have learned in, say, classical mechanics or sound or heat or thermodynamics. So quantum mechanics has its own ideas. So you will have to develop a different kind of intuition, and you build that intuition, in this case, gradually. So you will have to go through the mathematical analysis using the postulates to first get to become familiar with the machinery, and over a period of time you will develop the intuition and start feeling comfortable with the subject. But that's the way it is. So I don't think one can get around this one. So it's better to accept it. This is the way nature is, and try to understand the postulates and go from there. It's perfectly fine to be confused, it's perfectly fine to be uncomfortable, but if that's the way nature is, so be it. We just need to suck it up.
Thank you everybody. So shall we'll go to the second part?
Yeah.
Ready? We thought we can talk about some of the challenges confronting educators and also teachers when it comes to quantum science, quantum physics education. So basically we are looking at the challenges as educators and also as teachers. Would you like to start, Shankar? You had some very interesting questions other than
Specifically speaking, from the previous slide, fascinating point was that I saw superposition of being confused and being excited. That was
Can't make sense out of it. 28, 27, 28. That was before.
there are several eigenstates, ma'am.
So that was a fascinating point of it. Next, I think I feel that quantum mechanics is really important to learn, and I think transition from classical to quantum logic.
Challenging,
Yeah, that,
in what sense? Is it the mathematics? Is the physics feel mathematics? Which is the roadblock?
actually, that is also in a superposition because again, understanding the math and physics, again, it's quite hard because physics talks about how nature works. Mathematics is again the language of nature. So I think there should be a blend between the two. Of course, it's hard to understand initially, but that's what it is. We'll have to accept the fact that quantum mechanics is probabilistic. Quantum mechanics is not easy to understand, but at the same time, try to learn it, and because the future is dependent on quantum systems. So I highly feel that quantum mechanics is something that we should talk about right from schooling.
Very good, Shankar. That's very nice.
Yeah, just want to make a quick comment here.
Uh-huh.
So, unfortunately, the mathematics of quantum mechanics has received pretty bad press over years. In fact, if you look at, you can understand many profound concepts of quantum mechanics with elementary mathematics, not more than high school algebra, basic trigonometry, and 2 by 2 matrices. On the other hand, the mathematics to understand electrodynamics and classical dynamics and statistical mechanics are far more demanding, than the mathematics that you would require to appreciate good part of quantum mechanics. So I have a feeling that uh, attributing the challenges to appreciate quantum mechanics to mathematics is more psychological. It has just received bad press over years, but I think that's not true in my opinion. So you can learn quantum mechanics at a much deeper level with simpler mathematics in comparison with what you would require to appreciate classical electrodynamics and statistical mechanics.
That's quite true. I remember when I went to grad school, I had to do Jackson. Jackson, the Jackson.
Jackson will
Jackson
kill
was
anyone's
crazy.
interest.
Jackson mathematics was crazier than Griffiths. So in some sense, you can teach them Jackson's electrodynamics சொல்லிட்டு parallel quantum சொல்லி கொடுத்தா இதுவே பரவாயில்ல சொல்லி படிச்சிரோம். I'm just joking, but yeah.
So I have an opinion here again. So I would like to slightly disagree with what Shankar said and slightly with Ravi sir and partly agree with him. So my
They
point
ganked
is
them.
that
Researchers are ganged.
so my point is that see what we are used to is what we are always comfortable with. So thinking about why classical mechanics seems to be easier, but it actually has the difficult math part there. It's because we know that if there is gravity, things will fall. If there is a push, things will move. So it's very obvious to our eyes. We can't fathom anything. Even when we imagine, even in our dreams, when we imagine somebody going off a cliff, they might as well fly, but they do end up falling. It's your dream. The laws of physics are not really don't really have to apply there. But we are so subconsciously we are so how do I put it? So subconsciously we are so trained in such a way that this is how the world is. So there's only one small switch that needs to flip for you to understand quantum mechanics. So whatever you are observing in the macroscopical world, the world around you, it is very obvious to us. What you are going to be observing in the microscopical world, that is probably going to be that you can't see, which is why it is not being very clear, and by default we think that it's going to be difficult. So that is where I partly agree with him, where the basic math to understand quantum mechanics is not really that difficult. But at the same time, you can't just forego it either. You have to go through it. But how many of you have seen the movie Inception? Okay, so not much. It doesn't matter even if you have seen it or not. My point is that for you to build something, you need the slightest bit of imagination. If you have the imagination, you can build anything. So it sounds all very preachy types, but then imagination will help you understand physics in the most intuitive manner that I can probably ever say. And that very fundamentally I learned it from Ravi sir, how to understand physics intuitively.
Intuitively, another angle is as a challenge in other subjects, let's say electricity or magnetism undergrad level, there are experiments students can do and verify things, right? So quantum, what will I do? I have this problem, right? As a student, I'm in the classroom, the teacher's doing all this math, all that is fine, but electricity, at least I can see some potentiometer, meter bit, something I can do, galvanometer, ammeter, okay. Thermodynamic, engine, something is there, some measurement, thermometer, right? But so the question is, the experiments, can we show some experiments to students? That's a challenge teachers should face, right? How do we address this question? I'm sure a lot of teachers do have the same question.
This is a real challenge, and I don't think it can be easily addressed because do experiments in quantum mechanics, you need to know something more than quantum mechanics. So basically, to do experiments in quantum mechanics, we need to know atomic physics, you need to know condensed matter, you will need to use ideas from optics, so on and so forth. Because in classrooms, we always develop toy models and discuss ideal situations. But when you do experiments with electrons, photons, so on and so forth. And they are real physical entities that are going to manifest in real physical systems. So they are not going to confine themselves to classroom discussions. So you will have to take into account those additional challenges, and to address those challenges, you will have to know something. You will have to use quantum mechanics in more sophisticated situations. So you will have to learn other subjects like atomic physics, quantum optics, solid state physics, so on and so forth, depending on what platform you plan to do the experiment. So just to give an example, so this double slit experiment, the start experiment that we always discuss in quantum mechanics,
Double slit, I mean with electrons.
with electrons or photons, anything. The one that Professor Natarajan also mentioned this morning, was, the fact that when you try to observe the path of a photon, you lose interference. The moment you stop observing the path, the interference reappears. So that was first discussed as a thought experiment by Bohr, and later popularized by Feynman. In Feynman in his lectures in 60s. But the first optical realization of that experiment was done only in 1991 by Mandel.
That's a 30-year gap.
Okay? And Mandel had to use nonlinear optics to generate entangled photons, so on and so forth, to demonstrate single photon interference. So what was discussed as a simple thought experiment in the 30s, 40s, 50s, and 60s involved good deal of optics, good deal of nonlinear optics. He had to generate entangled photons, which didn't exist when these thought experiments were even discussed in classrooms. So, given this situation, I don't think some of the fundamental experiments of quantum science can be discussed in tandem with lectures, because you will need to know something more than what you normally discuss in the coursework. So I don't think this challenge can be easily addressed.
Can I add a point?
Yeah.
In fact, one interesting thing he pointed out was there was a 30-year gap. So earlier, it looks very short to me. If you look at Huygens wave theory, Huygens proposed a wave theory of light in 1670. Young's experiment was done in 1800 and something. So other 130 years. So 30 years looks very fast. So we are good. Quantum, I think we are on a better wicket than Huygens wave theory was some 300 years ago. So, so some other there is also this use of simulations, right? People as a substitute for real, actual hands-on. I'm not a big fan of simulations, by the way, as a teacher. And I want to fiddle with things. But again, okay, that's my personal thought. But people do use simulations, and there's a value in it. I do agree there's a value in it. So how do you think have you tried any simulations in quantum mechanics, Shankar?
Yeah, personally, from a student's perspective, just to build intuition, just to get a visual picture, I worked on a few free websites or few free softwares, and I tried working on superposition and entanglement. Yes.
What was your experience as a learner?
Yeah, actually it was quite hard initially, but just initially I just looked at equations. I looked at equations that explains quantum entanglement. But looking at that visually, or for example, when you look at atomic models, which is actually given in the form of a planetary model, which is of course inaccurate. When I looked at all these visual models using other softwares, that really helped me a lot in terms of understanding the atomic model much better. That also in fact motivated me to learn more about quantum mechanics, and that's what pushed me further. So I feel that all these technological aids can definitely come into classrooms that might possibly open up doors for students to learn more about quantum mechanics.
It's a good point. Again, reinforces the view that different people learn differently. Right? Some people like to do hands-on, some people can do the math. If somebody like him can want mix up everything. Right? Since the resources, the tools are available, why can't we make use of it? Your thoughts? Vala and
So
we are running short of time. We have got about 10 minutes more. Anna, we have to go to the third question also.
right. So I'll just be quick in what I have to add. There's just one small thing that I would like to point out, that simulations are not necessarily a substitute. So in some cases, simulations are where we are trying to map something that is not visible to our eyes to something that is actually visible to our eyes. It is like a projection. It is like a projection of what we understand to make it visibly understandable. So to start with, to work with simulations or simulations can be classroom experiments in a very gamified manner. There are like a lot of tools which have come forth with respect to growing the quantum mission. So in that way, understanding quantum mechanics away, separating the physics idea out of it, and understanding the quantum world, how things work internally, how do they work, how do we harness that aspect of quantum, so quantum science. So for that, we have quite a lot of gamified interfaces, free games, and a lot of free tools. So obviously these are split into different categories for beginners, for those who want to play with it, those who are serious about learning it, and those who have been learning it for quite some time. So the resources that I have mentioned here, so these are some of the software packages that one can actually make use of. And so from what I have done based on my work, I have given only Python based packages. There are also other packages, but most predominantly used or widespread users of these packages, especially primarily Qiskit by IBM. And the learning tools, if we say, from my point of view, the entry point into understanding simulations is by Python.
Nitya, I'm going to interrupt you.
Yeah.
Since we're talking about challenges and you mentioned all these things, what's the budget? People may not have budget for buying all
So
this.
these are
Free?
Yeah,
Good
Qiskit
news.
is free.
Good news.
So most of these for up until at least the intermediate level, the softwares, though the things that are published as softwares are free for the intermediate level. The code block itself is entirely free. You have to build the code for it. This is only the structure. It's a library. What you are going to be doing here, nobody can monetize on C++. It's a language. So Qiskit is like that. You are going to use it as a library, and you are going to code using that. So those who already have a background in computer science or coding will be able to make use of it in a much more easier manner. So yeah, this is one point that I wanted to add. I know we are running out of time, so just one main very important point. There was quite some talk about quantum computing, right? So quantum computing, in my opinion, is going to be the next biggest thing in the tech world, because we can see all the signs for it. There are quantum processors, there are quantum data centers coming up, and the primary difference between quantum computing and classical computing is the storage space required for a given amount of information. So in classical computing, we all know information is stored, say, in a form of an array, and we can say pick out, if we want to access a particular information, we can go and access it by searching for it or by looking for the address of that information. What happens, this is in case of a classical bit, but in case of a qubit, that is a quantum bit, what happens is information exists as superposition states. That is, multiple information is existing together. Whatever you want to access, you can access from it. So measurement here becomes a tool. So when you measure it, you can see only one information. But until you measure it, all the information is stored there in a single qubit. So this is when I'm saying it, it probably sounds simple or it probably sounds very complex. There's going to be no in between. But for
I'm not too sure. Maybe I hope that has changed for good in India. But that fear is more psychological.
The fear, I think, the classrooms, the teacher-student conversation, we had a sloka of Lord Krishna this morning, and I remember Bhagavad Gita. Bhagavad Gita, our culture talks about Bhagavad Gita, there's always this conversation with the student and the teacher. I think we have got an excellent example to emulate. Why can't classrooms be like Bhagavad Gita, where Arjuna shoots questions all the time and Lord Krishna has to answer? So conversation, classroom, like, not only in quantum mechanics, there has to be a more active conversations in the classroom. It's still, I think we are still stuck to that one way for a variety of reasons. I'm not blaming anybody, but this is what's happening. On the one way, the teacher is rolling off ideas and then shooting so many things at you, and I don't think it's that easy to grasp. And even for the teacher, if you tell me something about what you think, like we get, right? When we take the Menti poll, we get some sense about where the audience is, what the audience is, and you add value to the discussion, right? So now the conversation in a classroom can go a long way. So if we teachers can switch gears and engage students and promote conversation in a classroom, it can be, things can change. Deep, you got some add point to add? We don't have much time again. We are past time.
Yeah, so I wanted to address the two main points. One is curriculum and time constraints, and the other is about the lab experiments being too expensive. So, with respect to curriculum and time constraints, I believe this education of quantum should start very early, such that we can split it across years. So,
in school level,
yeah,
which grade level you want?
probably started at 9th standard level.
Like what is the
Game,
suggestion?
we can start it off as, so learning is very non-linear. It's not that they
Right.
have to be introduced to the first ever Huygens principle and then move forward in quantum mechanics. They can gamify quantum mechanics, play games with it, and have that as, say, a very playfully competitive thing. And once they get a sense of what it feels like, then they can, you experience this, right? So this is what it means. That would make more sense, is what I feel. At the 9th and 10th standard levels, a very gamified experience of quantum mechanics would be inculcated in them with respect to the experience. They may not understand why it's happening, but they will very well understand that it's happening. It's something that is happening, and that will get registered. And by the time they reach 11th or 12th, it can be explained as to why that was happening. So that is respect to time constraints. And lab experiments being too expensive, my solution is simulations. And there are also a couple of experiments, one or two, which is being taught at the first year undergraduate level, which can probably be taken to the 12th standard level. But that is the maximum we can push, because, like Dr. Bala mentioned, it involves a lot of other expertise required to do the experiment. So, yeah, I think we can move forward to looking at what are the ways
Thanks to the
forward.
audience for contributing. It's fantastic. So, right? We'll go to the third part, I think.
Yeah.
What next we can do. So these are some of the challenges. I mean, we are not, this discussion is not exhaustive. It's just to stir a discussion.
Yeah.
The way forward, what can we do as educators, all stakeholders, what can be done? Let's start with maybe Shankar for the third part, final part. These are some challenges. As a student, what do you think can be done to make things better?
Right now, currently, there are equal pros and cons in both the sides, because initially, for example, when we talk about introducing quantum mechanics to standard 9, at the same time in chemistry we have a chapter on atoms. So we have both. Over here in quantum mechanics we say that the planetary model is inaccurate, and in chemistry classes we learn in the same planetary model. So I feel that there's a slight conflict between the two. So I feel that students may feel a bit difficult, but yeah, I think of course thinking gives us a lot of different ways, but I feel that once by taking a step further, I think that will probably sum it up. So I feel initially it is going to be hard, but a few steps further may probably help us.
Very good. Thank you, Shankar. You guys have had something to add? What the way forward? What can be done?
So I think,
Simple solutions for real complex problems.
so I think I told what I want to say about gamified things. But
What is this Black Opal? What are the games?
So yeah, these are all online portals where they can play quantum mechanics based games.
Right.
So these are some things that 9th and 10th standard students can be introduced to.
Will there be any math?
No, they are like drag and drop, pick and choose,
Right.
such kind of games.
What are these? Really?
So for the 11th and 12th, they will be introduced to, since 11th and 12th, they are slowly getting introduced to matrices. They can understand what is a sphere, what is a cube, what is a cuboid, and they can be introduced to qubit. So a Bloch sphere is how a qubit is basically visualized as. So these concepts, they will be introduced as shapes and images, and then they'll be made sense of. So these are online platforms where these games can be accessed. So up until certain levels, these are free. They can also be accessed separately by institutions. Institutions can get institutional, I don't know, logins or something. So that is there. And with respect to this last videos part, I would like to very humbly request you all to consider Dr. Lakshmi ma'am's advice of choose the right videos to watch. Don't watch every video and feel that this doesn't make sense. If you start following someone, try to make sense of what they are saying as a whole. Don't just choose way too many people for different topics and get lost at the end. So, but this Kurzgesagt videos. So that Kurzgesagt actually means in German to make sense of. That's what it means. So these videos are very, very fundamentally given. So you can try it. So these are like sir said, this is just to stir your curiosity and what you can do further. This is not exhaustive at all. I'm just giving you an idea of what currently exists. So there are also more things that exist. You are free to explore them all.
I'm going to interrupt you. Can you suggest some nice, simple books where people can get hold of the math?
Okay, so I am a huge fan of the Demystified series.
It's a very good book. I used it. The Demystified series by David McMahon. Mahon, I think, something. It's a very good book. The PDF is available online. You can pick it up. It's a very good book. It takes you. It kind of hand holds you through all the math. But again, you have to spend time. See, you have to spend several days trying to master it. Like Bala said, you need to sit down and do things. So Way Forward also requires you to spend a lot of time if you want to master things. Any other book I would like to suggest?
So there is this good book written by Suhail Zubairi. So he wrote a book, Quantum Mechanics for Beginners. So this was an interesting book where Zubairi gave a course on quantum mechanics to first-year college students.
First year?
College students.
College students. Okay.
Even before they took their college courses on mechanics and electricity and magnetism. So he has not used any calculus for a good part of the book. He just relies on high school algebra, 2x2 matrices, and trigonometry. And he discusses a whole variety of phenomena. And he is a very good writer. He's a very clear expositor. So it's a good book to get started. And one little warning is, please don't rely too much on ChatGPT. It's a valuable resource. It's here to stay, but you should also figure out a way to use it. So that comes with experience. So once you get a grip over the subject, you will also figure out how effectively you can use it to your advantage. But don't treat it as your teacher, because the response, so the responses that ChatGPT throws at you will also reflect the ignorance of the person who's giving the prompts. So it's just going to be as proficient as the prompter is, or as ignorant as the prompter is. So please be careful when you use ChatGPT. And one last point is, it's good to take time to understand. So this is something that most of us can relate with our own experiences. When you graduate college, you feel that you have understood high school physics better. When you go to grad school, you realize that you have understood the undergraduate physics curriculum better. When you get into research or work in a national lab, you feel that you understand your own dissertation better. So that's what it is. It takes time. You don't learn everything necessarily through coursework. You learn more when you discuss with your friends, colleagues, when you chat in the corridors, over coffee breaks. Those which may sound they might look like trivial discussions, but they really enrich you a lot more than just formal coursework. So a whole lot of things contribute to your understanding, and they take time. It's a combination of all these things that will make you feel comfortable with a subject. So it's perfectly okay if you take your own time to learn something. You have your whole life. It's not a rat race. So I don't think one has to be obsessed about trying to understand everything in a few weeks' time. I think that can be counterproductive.
Since you mentioned the Way Forward, when I applied for my university, Purdue, before I went to Purdue, I was preparing. So one student, one of my former students, PhD, Purdue, he called me up and said, Ravi sir, Now you got an admission into Purdue University. Have you started preparing for the courses? சரி சும்மா படிச்சிருக்கேன் அப்படின்னு ஏதாவது புக்கு எடுத்து ப்ராப்ளம் சாப்டர் பை சாப்டர் போட்டிங்களா அப்படின்னு கேட்டான். இல்லைடா நான் சும்மா ஜென்ரலாக படிச்சுட்டு இருக்கேன். ஐ செட் தட்ஸ் நாட் த வே யூ லேர்ன். யூ வாண்ட் டு சக்சீட் இன் கிராட் ஸ்கூல் பிகாஸ் ஹி வாஸ் மை ஸ்டூடெண்ட். என்னோட சின்ன பையன், 15 வயசு சின்ன பையன். பட் he's a PhD. அவன் PhD பண்ணியிருக்கான். he knows the grind of grad school. his suggestion was, sir, ஒரு புக் எடுத்துக்கோங்க, சாப்டர் பை சாப்டர் போடுங்க, சும்மா மேலோட்டமா நுனிப்புல் மேலாதிக்கோ. that was his advice. I said என்ன சொல்றான் அவன், பேஜ் பார்த்தா புரிய மாட்டேங்குது, ஃபர்ஸ்ட் சாப்டர் பார்த்தா ஒண்ணுமே புரியும். ஓகே ஐ கோ டு செகண்ட் சாப்டர். சரி சும்மா போட்டு பார்த்தேன். ஒரு few weeks it took for me, then I moved faster. So I would suggest that approach to you because that was suggested by a student and it worked for me. ஏதாவது ஒரு புக் எடுத்துக்கோங்க. Let's say Griffiths. Spend a lot of time, like Bala said, a lot of time. You have to invest. Nothing comes without effort. Correct? Shankar, you agree with me on that?
Yes.
So the way forward, I think, for me. Anybody else would like to add a thought?
One last one.
Please.
Yeah, so we saw about the way forward for school students. So I also had some information to add for undergrads. So undergrads who are trying to get into quantum, probably make it your career, there are two ways. So one is research, obviously. If you're getting into research, quantum, you will anyway end up like our panel members said. By the time you finish your MSc, you'll probably understand your undergrad quantum better. So that way you will anyway move forward. But other than pure research, there are way many opportunities for undergrads to make use of quantum science. So primarily because the whole point of this colloquium is it's being organized as a way forward for the National Quantum Mission, right? So there are a lot of people who are harnessing that very fact, and companies have separate quantum committees. So where they hire engineers or resource people or subject matter experts to basically build their existing software architecture in a better way to be such that it can transition into the quantum world in a much more efficient way. So these are jobs that not many people are very aware of. So it is there and it is very much existing right now, and I'm sure I think pretty much most of the companies have it. Yeah, so here I only explained the job. I'm just mentioning the companies also have it. So these are the different kinds of jobs you may get if you get into quantum in industry. So quantum is not just
industry now with a bachelor's degree they cannot hope to do all this.
No, with a bachelor's degree they can get certifications and still apply for these.
Okay.
So if the company can believe that they know enough quantum, they will still hire them. It doesn't matter if you don't have a PhD. PhD is not the only way into this part of industry.
See, industry will look at one of the skills.
Yeah,
do you have
they
the
only
skills?
exactly
Not
they
the
only need
paper
your skills.
you get at the end of the course.
Yeah,
right?
if you
get the
understand
skills.
quantum well enough to make, say, to build a game, that will become your own business idea and you can sell it to schools. So the very aspect of understanding quantum can be monetized. So, and the most fundamental math, in my opinion, that's needed is algebra and linear algebra. Know your matrices well and you can at least get through quantum mechanics and understand it well enough. So, so this is just a picture of what the National Quantum Mission has right now. So it has got what are known as the T-hubs, and these are all the institutes that are part of the T-hubs. This is not an exhaustive list, you can check out the government's website, but these are all the institutes which have specifically made committees to take this mission forward, so they offer opportunities and internships in this field.
Sentence still there.
Oh, the application actually opened, so I thought it's still there. Maybe. Okay, yeah, so take it with a pinch of salt. Maybe not, it may not, all of it may not exist. But still, you can try to look for internships specifically in this field which are being offered on account of this National Quantum Mission that's going on.
So now available for undergrads?
Yes.
Okay, so that's important.
So,
Again, am I right in saying that don't think when you apply, it's all about getting into it and then learning on the job.
yeah.
right? So it's please, as you said, right? She said, learn. I think Bala said,
Learning is not
learning is non-linear. So it's not like நம்ம எல்லாமே கத்துட்டு அப்புறம் we'll do this. That's not the way it works, right? You just start learning, something all will happen along the way, and you figure it out. So don't try to say, don't say இதெல்லாம் நான் basic maths ஃபுல்லா கத்துட்டு அப்புறம் தான் I open the quantum mechanics textbook. You'll never open it. So, so just get your hands dirty. You get it. We are done, I think. And the last poll. The last is open-ended. Please share your thoughts on one takeaway or how many takeaways?
last one. Next one.
The next question, final question, is open-ended. No?
Yeah.
It's option kadayadu. So you need to type short sentence or you can type it.
Next one. Yeah.
What did you take away from this session? Some discussion we had. What do you think is the takeaway for you?
I think in this case, the response should be displayed.
And Deepthi says that your responses will be displayed in this case. Type in short sentences so that it's easy.
Slide it, not slide it.
Oh, yeah. Huh? Oh, is it because of the numbers?
Exceeded the numbers. Reach the maximum. Yeah. Now
Is that the reason?
Now it's coming.
It's coming now?
It's coming.
Oh, okay. One minute. Very good. Oh yeah, good. Oh, it's a real-time display. It's fantastic. Learning is non-linear. Well, we can read up. Need more imagination. Read about all the options.
Need more imagination. That's the second response.
Very
Very
useful.
useful, very interactive. Get confidence to open quantum mechanics book.
The big first step.
Get our hands dirty.
Griffith's நல்ல book. Definitely is an excellent book. Griffith's an excellent writer. You should also catch hold of Griffith's book on electrodynamics. Fantastic book. Griffith's writers you don't come across that often. கொஞ்சம் நிறைய கிரைண்ட் மாதிரி ப்ராப்ளம் வேணும்னா ZTLE எடுத்துக்கோ. ZTLE வந்து நிறைய ப்ராப்ளம் ப்ராக்டிஸ் நம்ம டெக்ஸ்ட் புக் 9th ஸ்டாண்டர்ட் 10th ஸ்டாண்டர்ட் ஸ்டேட் போர்ட் டெக்ஸ்ட் புக் மாதிரி இருக்கும். நிறைய ப்ராப்ளம்ஸ் கொடுப்பாரு, சொல்யூஷனோட கொடுத்துருப்பாரு. ஸோ அப்போ முதல்ல படிக்கிற சொல்யூஷனோட பார்த்தா ஒரு அட்லீஸ்ட் பாதாதுக்காக படிக்கலாம் சொல்யூஷன். Mean you need to get into the grind, right? ZTLE is a good book. Oh yeah, lot of questions going on. Lot of response. படிக்கலாமா?
Yeah, it's very interesting. Feel confident to give quantum mechanics a try. Wish to learn, read and understand more quantum science from the scratch.
I'm not the one to face challenges in the
Wow, there's somebody who's a super expert here. Very good. We skip past some responses. It's okay to have fear in the beginning of this, okay? Oh, this is a good one. See, I thought I was the only one confused a lot more.
That's the whole point of this poll.
So you're not alone.
Open the quantum book without basics. It's fine to start.
Yes. To not focus on learning everything and be patient during a learning journey. Okay? Need perseverance. I mean, that's whatever anything you do.
Long way to go in learning quantum mechanics, but then how to communicate these ideas to first generation learners who learn in Tamil medium. They seem to be left out of such learning. That's
A big challenge.
Very good
English is not our first language. நீங்க எழுதுறீங்களா?
நாங்க translate பண்றோம்.
Fantastic.
தேஷ்வரோட 3 chapters translate பண்ணி ஜூன் ஜூலைக்குள்ள முடிக்கும்.
Bravo. Give a big hand. Wonderful. Okay, fantastic. தமிழ்ல படிக்கணுங்கிறது தான் என்னோட பாயிண்ட். என்னோட டீச்சர் நான் கத்துன பிசிக்ஸ் ஃபுல் அண்ட் ஃபுல் தமிழ் தான் படிச்சேன். He was a professor here in Vaishnav. ஃபுல்லா தமிழ் மீடியம் தான் படிச்சேன். 10th
Wow,
வரைக்கும்.
that's it. Need more Krishnas in our classroom. I don't know whose comment is that.
யார் பாரு கிருஷ்ணா? ஓ, ஓகே. இது நான் சொன்ன எக்ஸாம்பிள் பா.
Possibly anonymous poll.
I said Lord Krishna சொன்னேன். Yeah. Very good. பட் அர்ஜுனா இருக்கணும் இல்லையா? கிருஷ்ணா வந்து பதில் தான் சொல்றாரு. பட் அர்ஜுனா கேள்வி கேட்கணும் இல்லையா? சோ நீங்க தான் கேட்கணும்.
அவங்களோட knowledge டெஸ்ட் பண்றதா இருக்கக்கூடாது.
Oh, yeah.
என்னமா?
Question should not be அவங்களுடைய knowledge அவங்க they want to express in Romari Kuda. They should come and learn.
ஆமா
Nowadays it is like that.
அந்த
They want to
humility
show
ஓட
their.
ஆமா ஆமா
That is not the problem. Your excuses and laziness are.
there's some philosophy here.
No, that's a beautiful comment. That one. That is not the problem. Your excuses and laziness are.
Recommended demystifying quantum. Very good. I know now. I know. I feel relieved that even my teachers do not understand quantum mechanics. And 5 minutes சொன்னாரு. Feynman said right. It's about
Nobody understands quantum.
Feynman said nobody understands quantum mechanics. No, that's okay.
And that was rather than just learning Young's double slit experiment, introduce the word quantum mechanics and anomalies early on, so that confusion begins early and the curiosity and work begins early.
That is there, but Anna, it can be a very uncomfortable. It can be uncomfortable for learners. See, you have to. You got to be learned to get used to being uncomfortable. It's okay. Just struggling with things is fine. Purma, what response? 34 people respond பண்ணிருக்காங்க. Fantastic. Sorry, we could not read all your responses. அப்படியே அவ்வளவுதானே? What's gone up is gone. That's it, is it? Can we scroll down?
They can scroll up.
Oh, we can. Anything else which you can read? Fiddling without mastering basics is actually useful. Yeah, that's so these people said, right? Learning is non-linear.
No time to think.
Learning is non-linear is a very powerful statement. Think பண்ணி பாருங்க. Reflect on that statement a lot. It's a very powerful statement. I think that's enough. Right? Thank you, everybody. You got some thoughts before we close? You got some thoughts to close?